Okay, let's take a brief look at the immune system. So humans, us, we have three lines of defenses. Okay, so three lines of defense. The first line of defense, second line of defense, and a third line of defense. The first line of defense, okay, has to do with your skin and your mucous membranes. Okay, so what this means is this. So how do you defend yourself against infections, against pathogens, against bacteria, against viruses? Well, you're built already with defenses, okay, that are going to help you um, battle any kind of foreign stuff in your body. And the first line has to do with pretty much the outermost parts of your body, right? For example, your skin. Well, your skin is going to be shedding all the time, right? Which by shedding means you're probably going to get rid of bacteria that is living there. Okay, mucous membranes, like we talked about it in the respiratory PowerPoint. Well, the mucous membranes have this mucus and has cilia, and so it kind of protects you by getting rid of some of the trapping, some of the bacteria or pathogens, and get them out of your body. Okay, so that is going to, and these are going to be kind of outer parts of your body. Okay, so the first line of defense have to do with outer parts of your body. Now you're saying, well, skin makes sense, right? But the mucous membranes inside your body, you're saying, wait a minute, but that's inside of your body. Well, yes and no, because if you think about it, uh, let's say you put something in your mouth and you eat something. Okay, you eat a concha, and you're eating the concha, but the concha comes from the outside, right? And technically, it's still going to go through a canal, through a canal, and the canal is still kind of part outside, right? Because it has kind of access to the exterior part of your body. So you put in something, and even though it's a canal inside of your body, it still is kind of facing things that come from the outside. Okay, so that's the first line of defense. The second line of defense has to do with some cellular, some cells. We'll talk about them, white blood cells, like neutrophils, like macrophages, like natural killer cells, and also some chemical defenses. Okay, things like, for example, proteins. Yeah, some proteins. Okay, that are going to protect us. Okay, to protect us against certain kind of pathogens. And then finally, we have the third line of defense. Okay, and the third line of defense is called the adaptive immune system or adaptive immune response. And those are, you will see, those are very specific to specific parts of a bacteria or specific parts of a virus or specific to a specific pathogen. Okay, and when we talk about the third line of defense, we're going to be talking about the T cells and the B cells. Okay, let me make a little note here. First and second line of defense and second line of defense, these are what we're referring to as non-specific. They attack all the same way, all same kind of pathogens. The third line of defense is going to be very specific. Okay, specific to a specific antigen, to specific bacteria, to a specific portion of a bacteria, or a specific portion of a virus. Okay, so the first line of defense, like I was talking about, I was saying early on, it has to do with your skin. The cells are continually being worn away and replaced by cells below. And also the skin has a kind of a low pH, and this is going to help by preventing some pathogens to live in your skin. Some pathogens, some bacteria may need a higher pH to survive. So having a low pH environment is going to be detrimental to some bacteria. So that's a way of how how the low pH of the skin protects you from bacteria or viruses or other pathogens. The mucous membranes, for example, the lining of the digestive and respiratory tract. Uh, like I was telling you before, the stomach acid, for example, okay, the acid in the stomach, the pH of 2 that you have in your stomach, okay, and digestive enzymes as well, provide protection in the digestive tract. And this is very similar to what I was telling you about here about the low pH of the skin. So imagine something in a pH of 2. If you ever put a finger in an acid solution or a pH of 2, it's pretty much going to burn down your finger. So imagine put bacteria there or put some kind of pathogen there, and it's probably going to get destroyed. Okay, so that itself, not only the stomach acid helps you in digestion, it also protects you from certain bacteria, certain pathogens. And then the sticky mucus, okay, it's going to trap most microorganisms in the respiratory tract. We talked about this. We talked to this as the escalator, okay, escalator, okay, and also not only the sticky mucus but also the cilia in the cells, okay. So this and this, the cilia also helps, especially in the escalator. Something gets stick, you stick it with the mucus, and then the cilia kind of moves it up away from your respiratory tract, for example. Now, there's also fluids. You have fluids, okay? For example, saliva, for example, mucus, and for example, your tears, okay? And these protect you against microbes as well. Why? Because saliva, for example, and your tears as well, they have something called lysozyme. And lysozyme is an enzyme. And this enzyme destroys the cell walls of certain bacteria. Okay, so when you cry, maybe even if you think that tears are only for emotional purposes, they're not. Actually, it has lysozyme. It has bacteria. It has enzymes that can battle and can protect you against bacteria, and so and your saliva as well. Okay, it also has lysozyme. Okay, the second line of defense. These are going to be cellular and chemical defenses, and they include these three main processes. Okay, actually, there's another one called fever, and I think you had fever before. And the fever also, it's a response of your body, pretty much puts your body at a high temperature, which the high temperature will affect, for example, bacteria or organisms that want to invade you. Okay, and the high temperature can uh, can effectively get rid of bacteria, and it can also kind of you remember what happens with high temperatures to the proteins. The proteins can get unfolded, denatured. They can get denatured, and so these bacteria or fungi, whatever, that also has all this kind of the kind of proteins, the proteins will unfold and they won't work, and the bacteria or the fungi or whatever can eventually die. Okay, so the high temperature it's in itself a protection against you against pathogens. Okay, I'll put here high temperature. High temperature is detrimental. Okay, so we have for other processes, inflammatory response. We'll talk about that in a second. Cells that kill the invading microbes. These are going to be your macrophages, your neutrophils, and you have some proteins that kill the invading microbes as well. And these proteins are going to be pretty much two of them I'll talk about briefly. These are the complement proteins, and these are going to be the interferons. Okay, the inflammatory response, infected or injured cells release chemical alarm signals, like for example, prostaglandins, like for example, histamines, okay? And these signals are gonna increase blood flow to the area. Increasing blood flow means bringing more things into action into the area. For example, nutrients for cells to recover, to use, to recover them, to recover or to divide, to make new skin, for example, or new cells. Other white blood cells into the area, so they invite any more. More blood flow means more blood cells, means more proteins that fight infection. It means a bunch of other things that you need to recover from that lesion. Okay, it's gonna cause the capillaries to stretch and to become leaky. And again, this is important because, well, you bring all of this stuff, right? All of this good stuff that you need to battle this bacteria or whatever, or this cut. And well, you have to make the capillaries leakier so you can get those stuff into that injured area. And it's going to cause phagocytic cells to migrate to the site of infection and attack invaders. It's gonna be like an SOS call, right? When you know what an SOS is, you're like help, help, help kind of thing. So anyway, these phagocytic cells are gonna get this SOS signal from this area, and they're gonna go to this area and eat up the bacteria or any pathogen that is there. Okay, and this is kind of the example of the picture example of our inflammatory response. What happens? Some cells called mast cells release something called histamines, can say in these signals, and the macrophages again secrete cytokines. And these molecules, they're signaling molecules. I said over here, they're going to dilate and they're going to make them leakier. We're going to be attracting more neutrophils. Neutrophils are going to be some phagocytes. Okay, like phagocytes, for example, phagocytes, among other cells. The capillaries are going to widen. Okay, they're going to dilate and become more permeable. Again, like I said over here, permeable or leakier, whichever of those words you understand best. Okay, which is going to allow fluid containing antimicrobial peptides like proteins, enzymes, complement proteins, whatever you need in that area. Also more neutrophils. Okay, and finally the immune systems can digest the pathogens and the cell debris, allowing the tissue to heal. Okay, so you see here from this picture, you have a bunch of, you bring more neutrophils, for example, more red blood cells, for example, to the area. And this is, these are the signaling molecules telling these cells, hey, come over here, come over here. There's SOS over here, okay? And you see how these capillaries get leakier, right? They get wider, they dilate, they get leakier. So these cells, these neutrophils can then actually go into the area and start cleaning up. Okay, cleaning up the area, getting rid of the bacteria, for example. Okay, getting rid of this nasty stuff here. Okay, cells that kill that kill invading microbes. There's a bunch of them, but I'm just gonna summarize kind of 3 of them. Again, these are non-specific because they're part of the second line of defense. Macrophages, big ones, make sure you know that one. What do? They do phagocytosis. What is phagocytosis? Ingesting bacteria. They eat the bacteria, they bring it in, and they lyse it, they digest it, they eat it. Okay. Macrophages, usually they patrol the vessels of the body as monocytes. So monocytes are the cells. These are the white blood cells. Okay. What happens is when there is a pathogen or there's bacteria or something like that, then the monocytes become macrophages. It's like they get activated into macrophages, and they start doing phagocytosis. Neutrophils are also cells that ingest bacteria via phagocytosis. I'll show you phagocytosis in a little bit, what that looks like. They secrete chemicals, okay, to neutralize everything in the affected area as well. And then we have also the natural killer cells, which attack infected cells. And they kill by puncturing the membrane of an infected cell. Okay, they have two main proteins. They have perforin and granzyme, and they use that. The perforin, they're going to be use it to make a hole. Okay, and the granzyme, they use it because it's an enzyme that activates other enzymes or other proteins in a foreign cell, and it's going to make that cell, that bacteria, whatever, to commit suicide. Okay, or another pathogenic cell, whatever it is. Okay, it's going to go there and or cancer cells or virally infected cells, and they're going to make those cells to kind of kill themselves. Okay, and lead them to something called apoptosis. This is what phagocytosis looks like. There's some easy steps here. Just know the main idea. First was what happens first is cytoporia. Cytoporia is nothing but plasma membrane. You see how this is still part of the plasma membrane? Okay, so these are cytoporia. This is cytoporia, but there's nothing but just like an invagination of the plasma membrane. That's all there is. Okay, and it's going to surround the pathogen. So this is the pathogen. It's being surrounded. The pathogens aren't going to be engulfed. That means they're going to be brought in by something called endocytosis, which we talked about this some time ago in terms of active transport. So it's like, wrap them up. That's what they do. They wrap them up in a little bag, for example. The vacuole forms, like you see here, enclosing the pathogens. Now it's inside, and really nothing's going to happen until you have other organelles called lysosomes. We talk about this in the chapter of cells, and lysosomes contain enzymes. The nasty looking enzymes. So what happens is this lysosome is going to fuse with this vacuole, like you see over here. They fuse together, and now the enzymes are able to enter, the vacuole here. And once they're together, they start breaking apart the poor bacteria. Okay, all of these toxic compounds and lysosomal enzymes destroy the pathogens. Great. And then what happens? Well, they have to get rid of it. So they release these pathogens, or the debris, okay, from the pathogens are released by exocytosis. And exocytosis is the opposite of endocytosis. Okay, exocytosis is throwing things out of the cell. And this is the natural killer cell, like you see over here. This is perforin. Perforin are a bunch of proteins that are going to make a pore. They make a pore in another cell. Okay, then eventually granzyme is going to come and it's going to lead this cell to die. Okay, or sometimes not even that. Sometimes there's another mechanism where it makes a hole or a pore, and a lot of water can come inside, and it's kind of explode. It will make the cell explode. Okay, so those two are the mechanisms that happen, and we'll talk more about this in another slide when I talk about the cytotoxic T cells.